Okay, so we have moment, and we say this is going to be this is an example of range. So we call this one moment center. And this is my moment arc. And you need to know the angle so that you can put effective moment like this. In particular, you will need to know whether it's positive or negative based on whether it's clockwise or counterclockwise. So for the force you put on range over here, is that going to be positive or negative? Negative, right? Because in this case, it's going to be what? Clockwise. So when it's clockwise, it's negative. Okay? Example. So control bar AB is inclined at 50 degrees from the vertical. The 100 Newton force is applied to the bar at end B. Determine the magnitude and direction of the moment. This force creates at the moment center at A if alpha equals to 140 degrees and B alpha equals to 180 degrees. So this is alpha. Okay. So again, we would like to define what are given or we need to find. So we are given a force applied to the bar, which is 100 Newton. Okay, and the incline theta over here is 50 degrees. I would like to know A, the moment when alpha equals to 140 degrees, and B, the moment when alpha equals to 180 degrees. Okay? Since we have force involved, it's better to have what? We got diagonal. So in this case, I have a bar. This is a 3-by diagram. Yes?
Are there any length measurements for that?
The what?
Are there any like length measurements? When we need this?
Oh, you mean the length measurement?
Yeah.
Yes. I forgot to put it. Yes, it's 1.2 meter. Okay? And one other given is, where is the moment center? A or B? Based on the problem statement, it's going to be at A. So everything is located around point A. Okay? Let's start. So A alpha equals to 140 degrees. So can anybody tell me, based on the problem statement over here, what is, I know the moment center is going to be at A. So can anybody tell me what is the moment arc? What is the length of moment arc? Let's say this is B. Is that going to be 1.2 meter, or is it going to be 1.2 meter cosine or sine 50 degree or 40 degree? Or it just 1.2? Any opinion? How many of you say it's just 1.2 meter? How many of you say I need to consider the angle over here? You don't need to. This is 1.2 meter. Why is that? Because, keep in mind, you need to know how your force is going to look like. In this case, the force over here, 100 Newton over here, it applied at where? This point. So, when we say we're going to have one effective moment created to this bar, this force, the only thing you need to know is how much the force projected to the direction perpendicular to the moment arc. Now, I know the moment arc is going to be here. The only thing I need to know is what? How much this force projected to the perpendicular direction over here. So, if it's going to be parallel to the moment arc, it's not going to create any moment. But when it's perpendicular to the moment arc, you're going to create the moment. Does that make sense? So, I don't care how much angle here. The only thing I care is alpha. So, this angle, 50 degree, can be anything. It can be 90, it can be 100, it can be 180, it can be 300, it can be 320. It doesn't matter. Because the only thing we need to know is 1.2. That is it. And the other thing we need to know is alpha, because this determines how much the force is going to be projected along the parallel direction or perpendicular directions. Does that make sense? So, now, since I know alpha equals to 140 degree, as I said, I need to know how much this force projected over here. So I know this 140, but actually, what I need is this angle over here, or this angle. Let's use this angle. So let's name this angle B, because I used theta already. Okay, so I use B over here. So when I say this 140 degree, what is the angle of B? 40. B becomes 180 degree minus alpha, in this case is 40 degree. And I'm talking about the perpendicular force. It becomes F. Equals to force multiplied by sine phi. In this case, sine phi is 40 degrees, so you can know this is a 100 multiplied by sine 40 degrees, which is going to give me 64.28 Newton. Okay, so second question. Is this going to be clockwise or counterclockwise? Clockwise, right? So when it's clockwise, is this moment positive or negative? Negative. So M equals to dF. D is what? 1.2 meter. F is what? 64.28. That if you multiply those two numbers together, you're going to get 77.13. But as I said, this is what? Counterclockwise. You're going to give me 77.13. Now, unit. What is the unit? Newton meter. Keep in mind, this is metric unit, so don't use pounds. Again, I didn't say anything over here, but it would be a good idea when you are trying to identify the given and find over here. If you confuse yourself a lot of times, you probably want to say this is metric or it's English unit, so you know which unit you're going to use, feet or meter, Newton or pounds. Okay, so this is going to be the answer. Question? No? Now, if I say alpha equals to 180 degree, what is my feet going to look like in this case? 0 degree. Because my force becomes something like this. So when I find perpendicular, that is going to be F multiplied by psi B. How much this one is going to give me? 0. So since I have 0 force perpendicular to the moment up, how much moment I'm going to have? 0. Do I need to have positive or negative sign over here? You don't need to. If you want to say negative, I don't care, because it doesn't really matter. So this is going to be the basic idea how to calculate for a moment apply to a specific moment center. Is that clear? Everybody understand what I'm talking about? Any questions so far? So what's important over here is you will need to know where is your moment center. Once you identify your moment center, you need to know what is your moment arc. Once you know your moment arc, you need to identify how much force has been applied to the moment arc, in particular perpendicular to it. So if this force has some angle with the moment arc, find out the perpendicular one, because it can be parallel, it can be perpendicular. The parallel one is not going to create any moment. Only the perpendicular force is going to create some force to the system. So when you say this is perpendicular to this one, then you just multiply the moment arc with the perpendicular force. Once that's done, identify whether it's going to be clockwise or counterclockwise. Then put positive or negative sign in front of it. It's not difficult, but you need to know what you're doing, and you need to follow the procedure. Okay? The second example here is 2 gears. So consider two gears that contact at point P, which is here. Gear A pushes on gear A with a force 100 Newton at point P. The radius of gear A is 100 millimeter, and the radius of gear B is 80 millimeter. Coordinate S's are located as shown here. Find the moment applied to gear A by gear B, given the force orientation shown here. Okay, so we are given the force equals to 100 Newton. We are given that equals to 20 degrees. Okay, so find the moment at A. This one in itself is free body diagram, so I'm not going to draw free body diagram again. But this is so when I start to solve it, we need to find the moment R. In this case, what is the moment R? RA equals to 100 millimeter, RB equals to 80 millimeter. So in this case, what is my moment R? I'm going to apply the force at A, the moment at A. So what is the moment R? 80 or 100? 100. I'm going to apply at A. This is A. Okay. So the moment R in this case is going to be. Again, before you start to solve the problem, you need to know whether you're dealing with English unit or metric unit. What is the unit? This one here. Metric. So normally I would like to use normal meter, Newton meter, when I'm solving for the problem. So this one equals to what? 0.1 meter. So when you have those information, moment equals to B multiplied by F. B is something we know. What is my F? I know it's going to be 100 Newton. But is this the force I'm going to create for the moment? No. What do I need to find? Perpendicular to the moment R. In this case, this is what? Now, which point is my moment center? A. So when I apply a force over here, is that going to be clockwise or counterclockwise rotation? Obviously, it's going to be clockwise. So when it's clockwise, what do I need to do? Negative. So if you do the calculation, it's going to be negative 9.4. That's it. Nothing fancy. Question?
How do you know when to use cosine and sine?
Good question. That depends. Depending on how you use that.
Mm-hmm.
Okay? So what's important over here? You need to find out whether it's perpendicular or parallel to the moment R. In this case, what is that? Perpendicular. Sometimes you might find the force of the angle over here. If this is the angle over here, you need to use sine, because you always perpendicular to this thing. But since I'm given the 20 degree over here, I would need to use cosine in this case. So it depends. I cannot tell you whether you should use cosine or sine. It depending on how the problem is specified. Okay? Okay. The next part. This is also one of the most tedious part in this class. Three-dimensional cross product of two vectors. So when we are multiplying two forces together, there are two types of product. One is force product, which is something I'm going to talk about now. The other one is dot product. Anybody can tell me what's the difference between those two? When I'm talking about the cross product, there are two vectors in 3 dimensions. When you are doing the 3 dimensions together, you're going to come up with another value. That is still a vector. And that vector is going to be the moment. If you are talking about something in this class, it's going to be moment along x direction, y direction, and z direction. But when we are talking about dot product, it's a little bit different. I think that is in chapter 2. I didn't finish that part. So when we are dealing with dot product, we actually talking about how much force, how much. This is A. When I say A dot B, it's saying I'm going to project A onto B. It will give you only a number. This number is how much length A projected onto B. What does that really talking about? So let's say I'm standing here. That's how much. I'm standing here. When I have sunlight over here, I'm going to have what? Shadows on the ground. So it's kind of like this thing. You have your object over here. You want to see your shadow on the other vector or on the other directions. Then you use cross product. So let's say if I have A equals to 1i equals to j, I want to know this thing on 3i plus 4j. What am I going to do? I need to cross product them together. So I project A onto B. So when we do that, there is one important thing you need to know. One important rule. I dot I equals to 1. I dot j equals to 0. Okay? So in other words, only when they are the same direction, you're going to create 1. If they are different x's, it's going to be 0. Okay? So when you have this step, with this step, you cross product A with B. You're going to have this number multiplied by this number, multiplied by this number. I multiplied by 4, 1 multiplied by 4 is going to create 0 because that's I cross product J. Based on the definition, is 0. So if you say you want to find out A dot B, you're going to have 3 plus 8, which is 11. So if you project this thing onto this axis, you actually generate something which is 11. Okay. Does that make sense to everybody? That's something we define as our cross product. Now, if we're talking about cross product, it's going to be a little bit different because when we are dealing with cross product, it's more like we're dealing with three-dimensional stuff. So if I have A equals to xai plus sb ya j plus z a k b equals to xb I plus y b j plus z b k. I want to deal with A cross product B. It's actually, you need to put everything into I, J, and K, the matrix representation, and have XA, YA, ZA in the second row. XB, YB, ZB on the third row. So when we are doing this, the definition is going to be a little bit different. I cross product J becomes K, J cross product K equals to I. K cross product I equals to J. If we are inverse that, then we need to have a negative sign in front of it. Okay? I know this is a little bit tedious for you guys to remember. So let's do that. I, J, K. If I cross product J, it becomes K. K cross product I becomes what? J. J cross product K becomes what? I. So this is a sequence. If you follow this sequence, you're going to have positive sign in front of it. If you do something like this, J cross product I becomes what? Negative K. K cross product J becomes negative I. So if it's in this direction, it's positive. In this direction, it's negative. It might be easier for you to remember what's going on. How about I? If they are the same axis, they are 0 because they are parallel with each other. When they are parallel with each other, it's 0. Just like what we deal with in a moment. Okay, is that clear? Everybody understand what I'm doing? Okay, so that is one thing. But if you want to explain this thing, how? It's going to be, you start from here, doing something like this. It's going to be YA, ZB, I. Go in this direction. is going to be ZA XB. Okay. Doing this direction, it's going to be XA YB. Now, that is this direction, and we also need to consider this direction. When it's in this direction, which is opposite, you need to have negative sign in front of it. So it's going to be XB, YA. Okay. For this one, for J, it's going to be XA DB minus. For I, it's going to be YB ZA I negative. So when you are dealing with this thing, you're going to have 6 terms. I know this part is somewhat tedious, and most of you guys is going to have problems with this kind of calculation. But unfortunately, this is going to be part of this class. And though we're not dealing with a whole lot of those kind of things here in this class, it's going to be a major thing in 242. If you are MAE, CE, or AE major, you need to take 242. This is going to be the core of that course. Okay. Any questions so far? Again, most of you guys is going to have trouble with calculating those kind of things. So please do a lot of practice. This is nothing but pure operation of numbers. So in order to not confuse yourself, be sure you practice this thing a lot of times. Okay? Example. So, when I say I have this kind of thing, and by definition, moment is going to be R. Let's put down F. Why is that? If it's 2-dimensional, we don't need to worry about that too much. You can just understand the direction of the force and distance away of between the moment center and where the force has been applied. So if you have those kind of information, by knowing whether it's going to be clockwise or counterclockwise, you know whether it's going to be positive or negative, right? But if it's going to be 3-dimensional, it's not that easy. When you apply a force to a specific point, it's sometimes difficult for you to say this is going to be positive in X direction or Y direction, because you just cannot visualize that clearly. For instance, the example over here. Okay, if I apply force over here, do you really know whether it's going to create positive or negative moment around x direction, y direction, z direction? Sometimes you can, sometimes it's just difficult. In particular, you are visualize the three-dimensional thing on a plane. It can be very confusing. So when we have this kind of things, we have no choice but put everything into cross product format so that you know after you do your calculation how much moment is going to be exerted on x, y, and z axis of the system. Okay, over here I actually have another force, which is F2 equals to ADI plus 40J minus 30K pounds. Okay, let's start. So this kind of problem, you don't really need to draw free body diagram because this one is actually free body diagram itself, so you don't need to worry about it. But still, I would like to define what I'm given and what I need to find. So I'm given F1 and F2 in vector representation, and I also given the position. I think this is A. This is B. A and B. And what I need to find is the moment at all. So how many forces are we dealing with over here? Two. Both forces are having individual moment R. So by definition, I'm going to have this equation actually equals to a summation term. This is going to be 1, this, and 2 combined together. So in order to do that, we need to identify the moment R at A and at B first before we move on. In this coordinate, I know this is positive direction, this is positive direction, and this is positive direction. So what is my RA? Five, I know it's 5. What is the unit? What is the vector over here? I, J, or K? J. That's something I mean. You need to be sure because sometimes it's just tedious. So you need to know which direction you're talking about. In particular, three-dimension configuration can be very confusing. How about B? Let's start from X. This is between here and here. So it's going to be positive 4. Right? And it's going to be from here to here, which is this point. So it's going to be positive 5J. Then K is going to be from here to here. That is 2. Okay, but it's downward. Because I'm using O as my reference point, so it's going to be negative K. Okay? Then M O is going to be RA cross product F1 plus RB cross product F2. So it's going to be 2 matrices that we need to deal with. The first row is always I, J, and K. Now, one of the mistakes you guys are going to make is you are going to swap the position of R and F. If you do that, you're going to see the magnitude part is going to be correct, but it's going to be opposite sign, which means if it should be positive. After a calculation, you're going to give me a negative. number. The numerical part is going to be correct, but the sign is going to be incorrect. So be sure you put R in front of R in front of F. So in this case, it's going to be 0, y, 0. F1 is going to be negative 60, 40, 40. For the second part of this thing, it's going to be I, J, K. The vector of position is going of moment up is going to be 4, 5, negative 2. Force is based on this thing. It's going to be 80, 40, negative 30. So let's start the cost product. Okay, let's start the first part. So when I do the first part, it's going to be 100. The other two are 0, so I don't really care. Plus, minus, this thing. So that is going to be my first cross product of this matrix. Does that make sense to everybody? So far. I skipped a lot of things is because those two are both zeros. So when you do the zeros, they are going to miss 2 terms over here and 2 terms on the opposite direction. So eventually you only get 2 terms from here. For the second one, it's going to be negative 150 I, this one, minus 160 J, plus 160 K, then minus 400 K, plus 80 I, plus 140 J. So you have 8 terms in this equation. Just add them together, you get your answer. It's going to be 30I minus 40 J plus 60 K. Is this the answer?
No.
What do I miss?
Mm.
Unit. In this case, what kind of unit I'm dealing with? Metric or English?
English.
When it's English, what is a unit over here?
Pound.
Pound foot pound, it doesn't really matter. Just give me this. That's your answer. This part, nothing fancy. E is just tedious. So be sure you have your patience to go through all the 6 terms for each matrix. If it's going to be 2 forces, 2 position vectors, then it's going to be 12 terms. Be sure you calm down when you are doing the quiz or the homework and do that carefully, one by one. Okay? We're going to talk more about this chapter tomorrow. Before I let you guys go, do you guys have any questions? Anything I didn't explain clearly, you want me to do that for one more time over here? Okay, if you don't have any